Hi, everybody. Happy Wednesday to you, the middle of the week. And tomorrow, I can't wait to see your smiley faces here back at school. I've missed you here. It's been kind of lonely all by myself. I can't wait to see you. Okay, so today we are going to do the chapter review, chapter 3 review. We did the whole chapter except for the very last lesson. You might say, hey, wait a minute, we skipped a lesson. It's just adding and subtracting decimals. You can do it if you want, but you already know how to. Just line up those decimal points, which makes all the other place values go straight in line as well. So we're just going to skip over that because you already know how to do that. Why waste our time? And we're going to do the chapter review today, which begins on page 225. So if you'll have that ready, first, let's start with our thinkogram. Let me share my screen here with you. All right, there it is. What do you think here? It's the word what. It's going up, not just once, but twice. So there's two what's. So what's up? What's up? Hopefully you got that one. What's up? Okay, let me stop sharing here. So right now we are going to do our chapter review. Tomorrow when you come to school on Thursday, or if you are still at home for some reason, a couple of you are, sadly, you can do the Canvas test online. Okay, our chapter 3 test is all on Canvas. I'll have it posted for you for tomorrow morning. The last, I believe, 3 questions on the test, I have written at the top that you may use a calculator for them, for those particular questions. Just like on today's review, we're also going to have just a few questions throughout the review where I'm going to allow you to use a calculator. So if you want to go find one, or if you have one on your iPod, or grab one out of your parents' junk drawer that they use to balance their checkbooks, and then we'll be set with our lesson for today. Okay, kiddos, so if you would take out your math book, we're on page 225. Let me share my screen again. We're going to zip through these problems, and remember, at any time you get stuck or need to rewind to listen to what I have to say again, or just pause me to slow down, that's why I have them videotaped for you, to do at your own time. And if you need to pause, you can do that. Alrighty, kiddos, so we're on page 225, and let's look at number 1. Also, if you prefer, if you'd rather do this all on your own and then go back and watch my video to check your answer, that will give you a good preparation for tomorrow's test as well. So if you would rather do that, that is super duper awesome. We've learned everything. You just need to remember it and apply it. Okay, kiddos. Number 1, it says Chaz kept a record of how many gallons of gas he purchased each day last week. And it says order the days from the least amount of gas to greatest. So we have to go from least to greatest. Here's least over to greatest. And it says order the days. So that means that we have to write Monday, Tuesday, Wednesday, Thursday, and Friday. So let's look first. We always compare numbers by the whole numbers. We have a 4, a 3, a 4, a 3, and a 4. Well, of course, the least number are the 2 3s. Think of it as alphabetical order. If you and your friend both have the same last name, you have to go to the second letter. But both of your last names, if they're, say, the letter A, and one's an A, a B, then A, P, of course the B comes before the P. That's how it is with numbers as well. So they're both 3s, so definitely Tuesday and Thursday are going to be first and second, the 2 least, but which one comes first? So let's look here. Now between these, we have to go over to the tens place. We have a 9 or a 7. Of course, 7 is smaller than 9. If you want to put a 0 up here and say, oh, 75 and 90, 75 is definitely smaller. So 3 and 75 hundredths is Thursday. So let's write Thursday in the first blank. I like to cross it off to say, hey, I'm done with that number. And definitely next, it has to be Tuesday because it's another whole number of 3. So Tuesday is second. All right, now the last 3 numbers, they all begin with a whole number 4. So now we have to go to the tens place. We have a 5, a 2, and a 2. Well, of course, 5's the greatest number here. So I could do that last. I definitely am going to put Monday last. So now let's go between Wednesday and Friday. They both are 4 and 2 tenths. So now I have to compare by the hundredths place. I have a 5 and a 5. Oh, that doesn't help at all. And in the thousands place, we have an 8 or a 6. Which one's smallest? Of course, it's the 6. So we have Friday has to come next. And then, of course, Wednesday. And of course, the largest number here is 4 5/10, and that is on Monday, where he paid for more, or I guess he got more gallons of gas. Alrighty, kiddos, those are our answers for number 1. Number 2, let me scooch this down here. Select true or false. We have 16 and 437 thousandths rounded to the nearest whole number. Remember, that's the ones place, is 16. Well, remember our little rule here. 5 and up, we raise it up. 0 through 4, it stays. So that's a 4. The 4 makes the 6 stay a 6. So that would be 16. So that is a true statement. Part B, 16 and 437 thousandths round to the nearest tenth is 16.4. So let's round to the tenths place. I'm going to underline the tenths place and look at the number beside it, the digit 3. The 3 makes the 4 stay the same. So that also is a true statement. And now it says for part C, that number rounded to the nearest hundredth is 16 and 43 hundredths. So let's go to the hundredths place and underline it. We have a 3. We have to look to its right, the 7. And think of this as a number 37. Is it closer to 30 or 40? Of course, the 7 makes a 3 round up to a 4. So it is not 16 and 43 hundredths. So that has to be false. It would be 16 and 44 hundredths, where the 7 made that 3 turn into a 4. So that is a false statement. Okay, we see here for number 3, I have the word calculator. So if you have one, go ahead and pull it out. And let's see here. We want to know how, well, let's read it together. Students are selling muffins at a school bake sale. 1 muffin costs 25 cents, 2 muffins cost 37 cents, 3 muffins cost 49 cents, and 4 muffins will cost 61 cents. If this pattern continues, so there's a nice sequence, a nice pattern here, how much will 7 muffins cost? And we don't have to explain our answer, because if you draw a chart, I can see your explanation perfectly enough. Okay, so let's start a chart by writing muffins at the top. We're going to count muffins up to 7, and underneath how much money they cost. Okay, you can pause me at any time. Leave a bigger space at the bottom for money so it doesn't get too squishy. And the question says, if this pattern continues, how much will 7 muffins cost? So I need to go up to the number 7. 5, 6, and 7. I might get squished there at the end, but that's okay. Okay, and now it already gives us the cost of the muffins so far. 1 muffin costs 25 cents. So let's put that in decimal form. And you don't need a dollar sign because our dollar sign is over here in our chart. 2 muffins cost 37 cents. So that's $0.37. You can see the whole numbers and the decimals, what they mean. 3 muffins cost 49 cents. And 4 muffins cost 61 cents. If this pattern continues, how much will 7 muffins cost? So we can't really figure this out until we find a rule for the pattern. Okay, it's already telling us there's a pattern here, so there must be a rule to follow. Are our numbers increasing or decreasing as we go on? Well, of course, if you're buying more muffins, it's going to be more expensive. So they are increasing, so my rule must be that I have to add. Add what? Do you remember from the other day what we have to do with these first 2 terms? You always subtract them to find the difference between them. And once you find the difference, we use that difference to add on to each of the terms. Okay, so let's subtract biggest number on up at the top. So let's step off to the side, 37 cents minus 25 cents. And let's find the difference between these 2 terms. 7 minus 5, 2, and 3 minus 2 is 1. So that means that every jump we're going to add 12 cents. So let's write that here. Add 12 cents 37 plus 12 cents will be 49 cents, plus 12, 61 cents. And now I have to keep using 12 cents to find 5, 6, and 7. So let's go to 4, add 12 cents. So we have 61 cents here. So let's step off to the side and take 61 cents plus my roll of 12 cents. Bring down that decimal. 1 plus 2 is 3, so 6 plus 1 is 7. So here we have 73 cents. You might even be able to fill these in your head. Let's add another 12 cents to find our 6th muffin. Bring down that decimal, boop, boop, boop. 3 plus 2 is 5, and 7 plus 1 is 8. We have 85 cents for our 6th muffin. And our 7th muffin, again, we have to add 12 cents. I'll put it underneath there. 5 plus 2 is 7, 8 plus 1 is 9. Bring down that decimal point, and here we have 97 cents final answer, and you can circle that in your little chart there. Oh, I did say you could use a calculator, so we could have just kept adding 12 cents, 12 cents, 12 cents. I did it by hand, sorry. We'll use a calculator another time. That wasn't so bad. Okay, flip please to 226. All right, what's the value of the underlined digit? And mark all that apply. Oh, where are we here? So we have the 6, and I see that the 6 is in the tenths place. Good, we have tenths, hundredths, and thousandths, the only 3 that you have to remember in 5th grade. So the value is 6 tenths. There we go. That cannot be because that says 6 hundredths. 6 tenths, yepperoo, buckaroo. 6 hundredths, no way. Oh, remember expanded form? There we go, 6 times 1/10. That is another way to write 6 tenths. All right, for number 5, we have a calculator sign here, so we could use the calculator, so you may pull that out. Let's read it first. It says, Rwanda jogged 2 1400 kilometers farther than Terrence. Select the values that could represent how far each student jogged and mark all that apply. So we have to see where Rwanda jogged this much farther than Terrence in kilometers. So if Rwanda would run 6 5/10 kilometers and Terrence ran 4 36/100 kilometers, did she run this much farther than him? Think about what I could do with these two numbers to determine if this is the difference between them. Good, when I hear the word difference, that means I have to subtract. So we're going to take 6 5/10 minus 4 36/100. Do I get 2 1400? Well, let's plug it into our calculator. If you'd rather do it by hand, that's completely fine by me. 6 5/10 minus 4 36/100. And voila, we get 2 1400. So that is a definite yes. And I can tell that that's right also because, well, Rwanda's number is longer than Terrence's because she jogged farther than him. So that means that her number has to be greater than his number. Okay, be careful. There might be a test question like this. Okay, here's another one. Rwanda, if she jogs 4 8/10 kilometers and Terrence jogs 2 76/100, if I subtract them, putting Rwanda's first, hers must be greater than his. If we subtract them, we must get a difference of 2 1400 if that's a reasonable two distances that they can run. Okay, so let's put 4 8/10 minus 2 76/100. 2 400. That does not say 2 1400. So that equals 2 400. So this cannot be a value that could possibly represent the values that they jogged. Okay, let's go down to the third one. Right away, you might say this minus this, and I bet that 5 65/100 minus 3 51/100. Look, it does equal 2 1400, but there's a little problem here. In this circumstance, Terrence jogged farther than Rwanda. That is not what happens up in the problem. So this third one cannot be, although if I subtract them, it will equal 2 1400, but that would be that Terrence ran farther than Rwanda, and that cannot be. Okay, that's a trick question there. Okay, let's go to the last one. Let's look at Rwanda's. Hers is greater than Terrence, 7 and 24 hundredths minus 5 and 1/10. Go ahead and plug that into your calculator. And the answer is 2 and 14 hundredths. So that is another value that could possibly represent the distances that they ran. There's 2 and 14 hundredths kilometers between the two. So the first one and the last one are both the correct answers only. All right, for number 6, you might want to take out a crayon. It says shade the model to show the decimal 542 thousandths. So remember, there are tenths going up and down here. This is a 100 block here, right? And this is one of the pieces blown up to show thousandths. All right, thousandths over here. And this is broken up into hundredths. So if I look here, I could just color in 54 hundredths, but 5 of them are going to be 5 whole rows of 10. So I'm going to shade in 1, 2, 3, 4, 5, just really quickly to show 5/10, which is a half. Okay, there's the 5/10. And then I need 4 extra hundredths. So here's 1, 2, 3, 4. And that makes sense because this is 54 hundredths. And that's what we have here. And we need to take this next block and blow it up to show 2 thousandths. So I'm only going to shade in 2 little parts in my thousandths. So there is 542 thousandths, all shaded in with my scribbly pen. All right, darlings, let's go down to number 7. And remember, if you're taking your time and I'm going on too quickly, just press pause. That's what I like about these video lessons, that you can pause me at any time. You probably wish you could mute me in class sometimes. Okay, number 7, Benjamin rode his bicycle 3 6/10 miles on Saturday and 4 85 hundredths miles on Sunday. How many miles did he ride Saturday and Sunday combined? So use these digits on these tiles. They may be used once or not at all, even more than once. Okay, so we're just going to take these two numbers, and you could do it one of 2 ways. Does it matter which number comes first? It doesn't. I usually prefer to use the first number in the problem first, and since it's a plus problem, I can do that. 3 6/10 miles on Saturday, 4 85 hundredths miles on Sunday. What can I fill in here? Of course, a 0. Do you have to? Not when you add. When you subtract, you do. Okay, let's add them together. Boop, boop, boop. That decimal point's already there for us. 0 plus 5, 6 plus 8, 14. Good job. Carry your 1. And a doubles fact here is 4 plus 4. And that would give us 8 45 hundredths. All right, darlings, on to the next page. If you need to pause me, use the restroom, or go get a popsicle, whatever you want to do, you can do that. Okay, let's see for number 8. The school is 3 65 hundredths miles from Tanya's house and 1 28 hundredths miles from Jamal's house. How much farther from school is Tanya's house than Jamal's? What does that mean? How much farther? How much more? That's always a subtraction problem. Okay, whenever we do subtraction, the largest number goes on top, 3 or 1. Of course, 3. 3 65 hundredths minus 1 28 hundredths. Line up those decimals. Can you take 5 minus 8? So, hey, 6, can I borrow from you? Sure, make me a 5. Put your 1 here in front of the 5. 15 minus 8, everybody? 7, good job. 5 minus 2. 3, bring down that decimal point unless you did already, and 3 minus 1 is 2. Word problems, we need a label. How much farther is Tanya's house than Jamal's? We go up into the problem and look at the words underneath or after the numbers. That is a good indication of what your label should be. 2 37 hundredths miles, or miles farther. Alrighty, go down to number 9. A vet measured the mass of 2 birds. In the metric system, the word mass means weight. So he measured the weight of 2 birds. The mass of the robin was that much, and the mass of the blue jay was that much. Estimate the difference in the masses of the birds. Okay, when we estimate, that means to round, okay? And if I would round both of these to the tens place, 76 would round to 80, and 81 would also round to 80. And if I have to estimate the difference, 80 minus 80 would mean there's no weight difference between them. So rounding to the tens does not make really much sense here. So let's round to the nearest whole number, which is the ones place. So let me write them over here. And I'm going to put the 81 and 54 hundredths on the top here. Okay, let's round to the ones place. Oh, you can't even see my numbers there. Okay, so the 5 makes this one turn into a 2. Good, so that's about 82 grams. And that was the blue jay. I put that one on top. And the mass of the robin, look, we want to round it to the ones place. Use the 6 next door. This 6 makes this 6 turn into a 7. Good. So this bird's weight is about 77 grams. If it says estimate the difference, that means I need to subtract those two numbers. 82 minus 77. You could probably get that one in your head real quick, but I can't take 2 minus 7. So I go next door, hey, 8, can I borrow from you? Sure, make me a 7. Put your 1 here in front of the 2. 12 minus 7 is 5. So one bird is about 5 grams, the blue jay is about 5 grams heavier than the robin. All right, let's go to number 10. It says Rick bought 5 yogurt bars at a snack shop. Yum, yum. Each yogurt bar cost $1.75. So we need to show the price of 2, 3, 4, and 5. And I have written here, calculator. So turn on your calculator, get it ready. If you have one of these at home, press on and clear. I'm sure you don't. But let's start with $1.75. That's for one. We need to add another $1.75 for our second. And that total is 3.5. Now when I think of that as money, I don't write money as 3.5. What do I have to put at the end in the hundredths place to make it look right? A 0. So that would be $3.50 for 2 yogurt bars. Okay, you could just take that number and press your plus sign again and add another $1.75 for our third yogurt bar. Did you get $5.25? Good job. Let's go down to the fourth one. Add another $1.75 for a fourth bar. So I just take my number that's already there plus $1.75 and a whole number 7. What would that mean? $7 whole, right? And when I write it in money, I just put 7.00. And that shows that these zeros really don't matter. It's just the whole number 7. I bet you could do the next one in your head. $7 plus $1.75. If you don't want to, add 1.75 and we get $8.75 for all 5 bars. All right, we don't do the quick pictures, so if you would flip the page. I'm trying to go quickly, but if I'm going too quickly, you can pause me at any time. Bob and Ling are playing a number game, pattern game. Bob wrote the following sequence. Oh gosh, guys, I don't like those commas. It makes my numbers look too squished, so separate them. Okay, first, we can't really find that unknown number until we find a rule. Okay, so look at my numbers. Are they increasing? That means I'm going to add. Or if they're getting smaller, decreasing, that means I need to subtract. From 28, 26, 24 down to 20, of course, my rule is to subtract. My numbers are definitely getting smaller. Now, what do I subtract? Well, if you take the first 2 terms and subtract them, you will find out. What number goes on top, 28 or 26? Good, 28 and 9/10. Subtract 26 and 8/10. Boop, boop, boop. Bring down your decimal point. 9 minus 8. 8 minus 6 is 2. And 2 and 1/10 is my final answer. Well, subtract 2 and 1/10. That's my rule. Now I have to apply that to find my unknown term. So if this minus 2 and 1/10 equals that, this minus 2 and 1/10, now I need to take 24 and 7/10 minus my roll. So step off to the side, 24 and 7/10 minus 2 and 1/10. Boop, 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 get that down there. 7 minus 1, 6. 4 minus 2, 2, and 2 minus nothing is 2. That's 24 minus 2, basically. So my missing number is 22 and 6/10. All right, number 3, who doesn't love a good picnic in the summer? This is about Raphael buying potato salad and macaroni salad for a picnic. He bought 2 15/100 pounds of potato salad. That's a little more than 2 pounds. And he bought 4 2/10 pounds of macaroni salad, a little more than 4 pounds. For these letters, 13A through C, select yes or no to see the true statements. Round it to the nearest whole number. That's the ones place. Raphael bought 2 pounds of potato salad. So go up here. Here's how much potato salad. If I were to round it to the ones place, that 1 makes the 2 a 2, right? So that is a true statement. So that is yes. Run it to the nearest whole number. I'm on part B here. Raphael bought 4 pounds of macaroni salad. So we have to go back up into the problem. Is this about 4 pounds if I run it to the nearest whole number? Does the 2 make the 4 stay the same? It does. 0 through 4, it stays. It's like the number 42. It's closer to 40 than it is to 50. So it stays the same. So that is a yes. All right, run it to the nearest 10th. Raphael bought 2 1/10 pounds of potato salad. So let me write that down here. He bought 2 15/100 pounds of potato salad, and it says round it to the nearest 10th. That's the 1. I look beside it. Does the 5 make the 1 stay the same? No way, Jose. That should round up to 2. So it should be 2 2/10. That 5 turns the 1 into a 2. So that is a no answer. All right, if you are into gymnastics, you understand this question. The 4 highest scores on the floor exercise, that's where they take the big floor and tumble and dance all around it. Here are the 4 highest scores. Let's separate those commas. Okay, choose the numbers that make the statement true. The lowest of these 4 scores, well, it might be easier just to see them here. They're basically lined up. Look, all of them have a 9 as your whole number. So let's cross that off. That doesn't help at all. Okay, that was the ones place. Now let's go over to the tens place. We have a 6, a 2, a 3, and a 5. Which one is the lowest there? 6, 2, 3, or 5? Of course, it's the 2, 9 25/100. How about the highest score? The highest score here, again, they're all 9s in the ones place. So we go 6, 2, 3, or 5. Which one's the largest number in the tens place? Of course, it's the 6. So 9 675 thousandths is the largest number there. All right, love bugs. Are we on our last page? Front and back, almost done. Okay, number 15. I think I need a quick drink real quick. Excuse me, as my water bottle drips all over me. Michelle records the value of €1 in US dollars each day for her social studies project. Remember what I told you before, when you go to a different country, you can't spend American dollars. They don't want American money. They need you to exchange your money for their money. Okay, so this is in Europe where they use the euro. That's the name of their money. And here is how much €1 is in American dollars. It says here, on which 2 days was the value of €1 the same when rounded to the nearest hundredth of a dollar? So that means, kiddos, that I have to round each of these numbers to the hundredths place. So let's go and underline the hundredths place, not the tenths. Go over to the second one over from the decimal point, the hundredths place, and let's round each of these numbers. Okay, here in the first number on Monday, the 8 makes the 4 turn into a 5. So this is about 1 45/100. We have to just round them all and find the two numbers that are the same. That's really all that it's asking us to do. Okay, let's go to Tuesday. The 3 makes the 4 stay the same. So that's 1 and 44 hundredths. What's not those two? Those aren't the same. Let's go down to Wednesday. We have a 5 underlined. Go to the number next door. The 2 makes the 5 stay the same. So that's 1 and 45 hundredths. Oh, I see it's matched, but let's double check with Thursday. The 8 turns the 5 into a 6. Good job. So that's 1 and 46 hundredths. So what two are they the same on which 2 days? I see Monday and Wednesday. The first and the third one down are both 1 and 45 hundredths. So we have to write Monday and Wednesday in the blocks there. Alrighty, number 16. Oh, we're going to use a calculator for this one too, kiddos. Now, whenever you use a calculator on the test on your scrap paper, I still need you to show me what you did to plug them in. So I'll show you that example right here. Miguel has $20. He spends $7.25 on a movie ticket. Wouldn't that be fun to go to the movies again? I haven't been into the movies in months and months, way before COVID. He spent $3.95 for snacks, probably like popcorn and a soda, and $1.75 for bus fare each way. Okay, so he must live in a city and he doesn't have a car. So in order for public transportation to come pick you up, so a bus to come pick you up, this isn't a school bus, you have to pay so the bus can pay for its gas and the driver. So you have to pay them to ride their bus. So look, he's spending $1.75 each way. So that means to go to the movies and to come back home, he has to spend $1.75. How much money does Miguel have left? Remember, he has $20 to start off with, and he's spending all this money. And let's, what do you think our first step is? Add up everything he spent, and then we'll have to subtract that all from $20 to see his change. Okay, so let's take our 4 numbers. This is what I mean. I want to see your work, although you could use a calculator, but we're going to show what we're doing now. We're going to take the movie ticket. We're going to add it to his snacks, which was $3.95, and bus fare to the movies, $1.75, and another $1.75 to come home. Let's add up those 4 items. You can use your calculator. Now, kiddos, on Thursday's test, there are definitely problems like this where you might have to look into the question and see, oh, $1.75 each way. So that means you need to put that in there twice. Okay, so you have to be a smart thinker. Let's add up these 4 numbers, $7.25 plus $3.95 plus $1.75 plus another $1.75. Press your equal sign, and I got 14.7. What does that mean? Well, 14 is my whole numbers. My decimal has to go there, and a 7 is in my tens place, so what must be over in my hundredths? 0, 5, 10, 15, 20, so I put down a 0. Some of you say, hey, I'd rather use paper pencil than use a calculator. That's fine by me. We just have to get you used to using calculators because of the PSSAs. Okay, you just at least have it to double check your work. Okay, so here's how much he spent, and it says he had a $20 bill. So how much money does he get to come home with after his night of a movie and fun? So let's take that $20 and subtract the $14.70 from that to find out how much change he has. Now you could definitely use your calculator, but I also like to see zeros up here and you practice using them. So if you want to use a calculator, go ahead, just double check that you have my answer at the end. Can I take 0 minus 0? Sure, put a 0 there. I can't take 0 minus 7. So don't you dare cross off that 0. You're not borrowing from it. You have to go next door. Hey, 0, can I borrow from you? No, I have nothing to give. Hey, 20, can I borrow from you? Sure, take 1 away from 20, make it 19. Put your 10 here, put your 1 there, so it makes 10 minus 7. We have 3. And 19 minus 14, or 9 minus 4 in this case, is 5. So $5.30 Miguel will have left. All right, darlings. Number 17. Yolanda has a sunflower plant. It was 64 and 3,400 centimeters tall in July, and during August it grew 18 and 2/10 centimeters. So it was this and it grew this much more. The first part, A, says estimate the height of Yolanda's plant at the end of August by rounding each value to the nearest whole number, the ones place. Okay, so let's do that. Let's write both numbers here, 64 and 3,400. And underneath it, write 18 and 2/10. But it says that we have to estimate, so we have to round to the nearest whole number. So we're going to add them, but let's change them first. Remember this little symbol that means about? This 3 makes the 4 stay the same, right? So that's about 64 centimeters. And it grew, this 2 makes the 8 also stay the same. So this will be about 18 centimeters. Let's add them together. 4 plus 8 is 12, carry your 1, and 6 plus 2 is 8. So we have here that her sunflower plant will be about 82 centimeters. Now it says here, will your estimate be less than or greater than the actual height? So I want you to think about this, kiddos. We had to round 64 and 3,400 down to 64. So that means we lost this much of the plant height. 18 and 2/10, we also rounded down. So we rounded it down so it's a smaller amount than it is. So if we rounded both of these down, this will be less than, or my estimate will be less than the actual plant size because both numbers rounded down. If I would round up, then that would be an overestimate, we call it. So we call this an underestimate. Because we rounded both numbers down, it's going to be an underestimate, or an estimate that's less than the actual height. Alrighty, so you can copy that. And part B says, was the exact height of the plant? What was the exact height of the plant at the end of August? So we can copy down the actual heights, 64 and 3,400, and add to it the 18 and 2/10. Line up those decimals, and let's add this up fairly quickly. 4 plus nothing, we could put a 0 there if we want, is 4. 3 plus 2 is 5. Bring down the decimal point. 4 plus 2, or 8 plus 4 is 12, carry your 1. So here is the actual estimate, and it says that it is in centimeters. And is your estimate greater than or less than the exact, or I'm sorry, was the estimate less than or greater than the exact value? And we can see here that our estimate, it was less than our exact value. Alrighty, hey guys, we're on our last page, finally. Normally in class, I would have you working with a partner to do this, and then we would go over it with markers, but that's how it works right now. Okay, it says Oscar ran the 100-yard dash in 12 and 4100 seconds. Josiah ran it in 11 and 8500 seconds. How many seconds faster was Josiah's time than Oscar's time? So how many seconds faster? How much more? That's a subtraction problem. When I take these two numbers, I have to put the largest one on top, 12 and 4100 minus 11 and 8500. Subtract, I can't take 1 minus 5. Hey, next door 4, can I borrow from you? Sure. 11 minus 5 is 6. I can't take 3 minus 8. Hey, next door neighbor 2, can I borrow from you? Sure, make me a 1 and put your 1 that you borrowed in front of your 3 to make 13. 13 minus 8, 5, and 11 minus 11 is 0. So 56/100 of a second is how much one ran quicker than the other. That's a close call. Okay, we have to make this statement true. And the number 1 and 25 thousandths, the value of the digit 2 is 2 what? What place value is that 2 in? The hundredths place, good. And the value of the digit 5 is worth 5 thousandths. Yes, yes, yes. Okay, for number 20, Troy and Lizetta are solving the following word problem. Rosalie's cat weighs 9 8/10 pounds. Her dog weighs 25 4/10 pounds. What's the weight of both animals combined? So if I'm just adding two numbers, can't you just put those two numbers together? Troy sets up his problem as 9 8/10 plus 25 4/10. He put them in order how they are here. But Lizetta switched it around and put the 25 4/10 first before the 9 8/10. Who's correct? What do you say? Both are correct. Why? Do you remember what property allows you to switch them around? Oh, I heard it. The commutative property allows you to switch the order. That's whenever you add or multiply. All right, kiddos, last problem. 84 hundredths is 10 times as much as what smaller number? Okay, so if I have 84 hundredths, I need to scooch it over to show that it's 10 times larger than what smaller number? The 84 has to scooch one more place value over into the thousandths place. Okay, if I scooch it all over once, it would be like that. Okay, this is 10 times as much as this. One place value jump to the left is 10 times larger. Off to the right is 1/10 of. Okay, but 84 hundredths is 1/10 of what larger number? So that means I have to take 84 hundredths and say that's the smallest number compared to 10 times bigger, which is right here. So what do we need here? 8 4/10. We need to scooch it over to show that this is only 1/10 of this number, 8 4/10. All right, that is it for today. Tomorrow, your quiz will be like that, but it will be mostly multiple choice and with only one correct answer. Okay, darlings, that was a lot of work you just did. You did an awesome job. I will see you tomorrow. If you have any questions at all, feel free to get on to our Zoom meetings throughout the day or just shoot me a quick email and I will get back to you as soon as I can. All right, darlings, enjoy your day. I can't wait to see you tomorrow. Bye-bye.